I'm Anil Kumar, sharing with you a question from my subscriber. Now, this one is serious, and I've been getting such questions many times. In fact, most of the time when I get a question is when there is a mistake in the book and students are struggling to match their answers and their thoughts. So, if you want to go through this video, go through it seriously, provide your comments, and try to get things corrected if you think they are wrong. Okay, so we are talking about 5.6 sine law ambiguous case. The question has been sent along with the solution by the student, and she wants to understand how to justify this solution. The question here is, determine whether it is possible to draw a triangle given each set of information, sketch all possible triangles where appropriate, label all side lengths to the nearest tenth of a centimeter, and all angles to the nearest degree. Question number 3C. A 5.0 centimeter, C 8.5 centimeters, and angle A equals to 36. Beautiful question, no doubt about it. And the best part is that question has specified each and everything, right? It says sketch all possible triangles where appropriate. We're talking about ambiguous case. Now, if the condition is that we have an ambiguous case, we might have two triangles, but the solution provided to me is just one triangle. So first request to my student is, or the subscriber is, I should say, to provide the other triangle also, whether it is included in the solution or not. Now, label all side lengths, it has been done, nearest tenth of a centimeter and all angles to the nearest degree, and then we are given some information. Now, if I want to write 5.0 centimeters here, and it has been rounded to one decimal place, what does it mean? This is what you have to understand, right? That means what? Does it include a value which is 4.9099, right? So, okay. So let's go forward and figure out the solution. Now let's get to the reason of this video. The reason is that when I also solved this, I didn't get that solution, and I have understood why. And I want to share that with you. Okay. Now we are given side A, which is 5.0 centimeters, side C, which is 8.5 centimeters, and angle A as 36 degrees. So let me first tell you how to sketch such a triangle. If angle A is given, I'll prefer to show it on the left hand corner, right? So let's say I just draw like this, and I'm saying that this is my angle A, which is 36 degrees, right? So angle A is 36 degrees for us, and the side whichever is given to us is one, A itself, which is opposite to this, and the other one is 8.5 centimeters. I like to keep this side on the top of this angle at this position, 8.5 centimeter. Don't go with regular ABC type of triangle, as it may make your life hell to really understand how to provide solution to ambiguous cases. So I'm saying this is my A, and since C is given us, so that point should be C for us, okay? That point should be C for us, correct? So let me write C here. And for the time being, I will just connect it. I really don't know where C will be, so I'm just connecting it with a line which may change after the solution. Perfect. And this is the point B for me. Now, since opposite to A should be here, I'm writing 5.0 centimeter. Does make sense to you, right? So that is the first thing. Whenever you sketch a diagram in context to this unit on ambiguous cases, keep A like this. Why am I saying so? The reason is very clear. What we do really is that we drop a perpendicular from whatever this vertex is down. And we say, well, let this height be h. Correct? Now, as you can understand, this height is opposite to 36 degrees. And therefore, we can say h is equal to, this height h is equals to the hypotenuse 8.5 sine of 36 degrees. Now, hypotenuse will always be the longest side, and sine and cosine, you know, are always maximum. They could be 1, so they're less than 1. So when you multiply, you'll get a value which is less than hypotenuse, so it makes sense. So that is a good check. Now let's use a calculator and set it to degrees. Sometimes my calculator is not in degrees, okay, and then calculate 8.5 times, I don't have to do times, but still 36 degrees, bracket close, it gives me 4.99, look at the value, 4.9961. So let me write down. So I get 4.9961. Now, the question here says, sketch all possible triangles where appropriate, label all side lengths to the nearest tenth of a centimeter. Now, the side given to me is 5.0. Could it not be 4.9961? That is my question. Could it not be 4. How will you round this? I think it should be rounded to 5.0. There's no other way to do it, correct? It has to be. Now, since h is equals to a, it means what? Now, it means that we have a right triangle, right? No? I suppose. So we are looking into the condition where there's only one triangle, and that triangle is a right triangle. So therefore, the triangle which I'm going to sketch is like this. C will come here. Let me call them a C dash. And this side is 5.0 centimeter. Perfect. Because I did all this calculation. This side is 5 centimeters. So we come up with only one triangle, which is a right triangle at C. And this angle will be what? 90 minus 36. Does it make sense to you? 54 degrees. So that should be my answer, right? And now we need to find what AC is. So let me write down angle B is equals to 90 degrees minus 36 degrees, which is 54 degrees. And to find side AC, I can use sine law, right? So I'll say AC over sine of 54 degrees. Now, here, whenever you're using sine law, it is actually good to use more decimal places, right? Since I'm not getting into real details, my idea is to discuss this part, which I think I've placed it fair and square, right? Now, well, I could use Pythagorean theorem. When I say right triangle, I will not use this, correct? So what will I do? I will say AC is equal to square root of 8.5 square minus 5 squared. Does it make sense? So let's use this, right? So I'll do square root of 8.5 square minus 5 square, right? And equal to, in decimals, it is 6.87, and that is rounded to 6.9 centimeters. Correct? So that is what I get from the given condition. So my answer is, this should be, let me write down, 6.9 centimeters. So that's my triangle ABC. So in our case, I get right triangle. Now, it is a good idea to discuss with your teachers and understand what are they expecting. And if we are expecting two triangles, we should have had another triangle kind of like this. Is it okay? Okay, where these sides are this, and you should provide with two solutions. In either case, I hope Well, this is best I can do for you. I hope it makes some sense to you. Take care and all the best.